Today we're going to talk about solving higher degree polynomials by factoring. We're going to be able to find both the real and the imaginary solutions of a higher degree polynomial. It's important to realize that the degree of the polynomial, meaning the largest power, indicates how many solutions you have. So if I have this polynomial, I have at most 3 real solutions. I might only have 1, I could have none, I could have 2, but at the most I will have 3 real solutions. So the graph could look like this, where it crosses 3 times. It could also perhaps only have 1 solution where it crosses like this. That means I only have 1 solution. If I only have 1 solution, that means that I have to have 2 imaginary solutions. And we're going to work on finding both the real and the imaginary solutions of a situation. We have several different methods of solving. We could factor using the difference of squares. We could factor by grouping, use the sum and difference of cubes, and for special situations, the quadratic formula will also work. So let's examine an example. Right away, by looking at this, I can tell that I have the sum of cubes, because 8x cubed is a perfect cube, and 27 is a perfect cube. Now, I could solve this by rooting. I could subtract 27 from both sides, and then divide both sides by 8, and then cube root both sides to get negative 3 halves. But that only gives me 1 solution. This graph will only cross the x-axis in one place at negative 3 halves, but that doesn't tell me the imaginary solution. So let's go back. And let's factor, because in order to find all of the solutions, I'm going to have to factor. So my factoring pattern for the sum of cubes states that I cube root both numbers. So 2x and 3. The sign is the same. And then I square the first term to get 4x squared, and square the last term to get 9. The last term is always positive. I do the opposite, and 2x times 3 would be 6x. Now, following my laws, or my rules of solving by factoring, I set each factored portion equal to 0, and solve further. When I solve this part, I subtract 3 and divide by 2, so that's my real solution. I could have found this solution without factoring. Now this solution, factors of 4 that add up to give me 9, that doesn't factor. There are no factors of factors of 36 that add up to give me negative 6. So I have to use the quadratic formula here. This is a quadratic. So x equals the opposite of b, so positive 6, plus or minus the square root of negative 6 squared minus 4 times a, which is 4, times c, which is 9, all over 2 times a, which is 4. And now I just need to simplify this. So 6 plus or minus negative 6 squared is 36. And negative 4 times 9 would be negative 144 over 8. And 6 plus or minus the square root of negative 108 over 8. And I should probably reduce that radical. It's a negative, so it's going to be an imaginary number. So technically I need to pull out the I before I can do anything. And I'll make a factor tree. 108 divides by 4 to give me 27. And that's 9 and 3. And 2 and 2, and 3 and 3. So it looks like I can pull out a pair of 3s and a pair of 2s to give me a 6. And I'm left with a 3 on the inside. So it's 6 plus or minus 6i times radical 3 over 8. And then I can reduce this every number, or every coefficient out front. Well, can divide evenly by 2. So 3 plus or minus 3i radical 3 over 4. So this represents all of the solutions. There is one real solution and two imaginary solutions. The plus or minus takes care of both sets of imaginary solutions. Let's do another one. Remember your patterns of factoring. This is a trinomial because there's 3 terms. As long as all the powers are the same number apart, you can factor it like a normal trinomial. So 4, 2, and 0 for the x power. So I can factor this. Factors of positive 12 that when I add them up I get negative 13 would have to be negative 12 and negative 1. So I'll factor this by splitting up the middle term. 4x to the 4th minus 12x squared minus x squared, or 1x squared, plus 3. And then I'll factor by grouping. So I'll pull out a 4x squared, and I'm left with x squared minus 3. For the second group, I need to pull out a negative 1, and I'm left with x squared minus 3. And I have for my 2 factors 4x squared minus 1 and x squared minus 3. Now before I even solve this, I'm going to go look back at the beginning. This is a 4th degree polynomial, so I should have at maximum 4 solutions, real or imaginary combined. So I'll set each factored portion equal to 0. And in fact, 4x squared minus 1, that factors further. That's the difference of squares. So I can say that this is 2x plus 1 times 2x minus 1 equals 0. I can't factor this one further. So x squared, I'll just get the x by itself and then square root both sides. And again, whenever you square root both sides of the equation, you include the plus or minus. So there's 2 solutions, plus or minus the square root of 3. And then here, I can set each factored part equal to 0. Subtract 1 and divide by 2, so x equals negative 1/2. Add 1 and divide by 2, so x equals positive 1/2. So my 4 solutions are x equals 1/2, negative 1/2, the square root of 3, and this negative square root of 3. Since I didn't have any fractions or x's in the denominators of my equation, I know that I can't have any extraneous solutions. So these represent all 4 solutions of this 4th degree polynomial. None of them were imaginary, but they certainly could have been. And we will stop there for now. Please write down any questions that you have, and we'll go over them in class.